Hello everyone. So we're getting more into the C programming language now, and one of the things about C is that it doesn't have objects at all. But it does still have a way to encapsulate different variables into one structure. And in particular, this is called a struct. So let me just dive right into it and show you. So if I define something called struct person, and let's say that a person has a name, an age, and maybe a birth year. Well, I can actually kind of treat that like a class and initialize objects of this type. So I could say struct person Chris, and I could say chris.name equals Chris, chris.age equals 35, chris.birth year equals 1989. And so just to show you that this compiles, well, it would help if I also added a semicolon at the end of this. Okay, so it turns out you need that just like classes in C++. Okay. So we can still encapsulate a bunch of variables into one kind of meta variable, but there are no methods in this. There's no information hiding, so no public, private, nothing like that. But this is still very useful if you want to, cut down on code and organize things a little bit more. And so, of course, I could, have a method where I pass this along. I could say, celebrate birthday. And then I could pass this along by reference. So I could say struct person. And then I could say person. So no information hiding. So I can just directly access. So I can dereference this and directly access anything inside of the struct here. So let's say person age plus plus. Maybe I'll have another method called print person. I could actually pass a struct by value too, if I wanted to. But that would make a copy. So let me just maybe continue to do it this way. So I'll say printing info. I'll say name, whatever, age. We'll just do the name and age for now. Say person, name, person, age. So let me just test these methods here. If I were to say, let's celebrate birthday of Chris, so I'm going to pass the memory address of Chris. So I'm passing this by reference, going to pass a pointer to it. And then I'll print person, Chris. And let's just see what that does. So if I compile this, of course I've been writing a lot of Python lately. I meant to say printf, not print. That's why it said implicitly declared function. Okay, so let's run this. And now it says printing info name Chris, age 36. So you see I was successfully able to call this method. I passed this by reference, so it incremented the age here. And then I had another method that printed information. Now, you can see these methods are almost acting like instance methods on this variable here. So you can kind of think of this like an object, and these are instance methods of the object. So we're kind of faking stuff about classes if we want to. Okay, so let's take this idea and do something really official here and make a linked list in C using these kind of fake objects. And so for a linked list, I first need a node class. So I'll make a class called struct node here. If you remember, a node has a pointer to the next node in the linked list. So I'll do that. And then it encapsulates some data at each node. Now I don't want to be too prescriptive about what the type of the data is, so I'll just make it a void star, a pointer to some arbitrary data. And I'm not even going to make it the responsibility of this node class to clean it up. So you pass something to this, it's kind of your responsibility to make sure that if it was dynamically allocated that you delete it, or if you're about to return for a method, you don't accidentally pass something that's about to go away. So in my design here, I'll make that the responsibility of the person who initializes the node. Okay. And then, of course, I need a linked list class. And the linked list class is actually quite simple. It just has a pointer to the head node, right? Okay. And so now what I'm going to do is let me try to think, okay, if I were actually going to treat these like objects, what kind of methods would I need? And in object-oriented languages like C++, Java, etc., we would need some kind of constructor and some kind of destructor. for each of these. So I'll just make the one for the linked list for now. So I'll say, okay, void, or actually, you know what? I guess I might as well go ahead and make the constructor make a totally new thing and return it. Okay, so it's kind of up to me. But maybe I'll say, okay, let's make this struct linked list. So we're going to return a pointer to a new linked list. Linked list init. All right, so a bunch of different conventions you can do, but I'm choosing here, okay, maybe every method that's of this fake class, I'll proceed with the name of the class, and then I'll follow it with an underscore and the name of some method. So what I'll do here is I'll say, okay, what you got to do for a linked list? Well, first we're going to make a new linked list, right? So if you remember, I have to use malloc, right? So I'll say struct linked list malloc, and so we're actually, it turns out, size of, let me get my head out of the way here. Size of also works with structs. It knows how big the structs are in memory, so I can say size of struct linked list. All right. So that is how I would make a new linked list. Struct, dynamically allocated, and then I'll return it. Oh, of course I should give it a variable name too. I'll just call it list here. So I'll return list. And the only thing I need to do when I initialize this linked list struct is set its head to be null, right? So I would say lists head equals null. Okay, so null evaluates to 0 in C. This is the null pointer. Okay, we're never going to have a valid memory address of 0, so the convention is to use 0 to meet null. All right, let me just make sure this compiles because I've written a lot of code. So, okay, good, it compiles. Okay, if we have an init method, we should also probably have a free method. And maybe there's more that I'll do with this later, but for now I'll just say void linked list free. And actually in this case, you're going to pass along the linked list that you want to clean up. And there's probably more I'd want to do later because I probably want to go through the linked list and delete each of its nodes. But for now, maybe I'll just, I'll say to do, clean up nodes. But I know certainly by the time I'm finished, I also have to free the pointer to the dynamically allocated struct that I made in the init method. Okay? So for every malloc, there should be a free, right? So if I'm calling this linked list init, I better call this free afterwards. Okay, so just to show how I might start off here, I could say linked list star list equals linked list init. So I'll call this method make a new linked list. All right, but now what makes this all exciting is that we can have methods to actually add data to the linked list, right? So let me make a method called linked list, void linked list add first. All right. So in this case, see, the thing is when you do it this way, okay, these aren't real instance methods. You always have to pass the struct as the first argument. And usually, you're going to be passing it by reference. This is the convention that kind of makes sense. Okay, so I'm going to do it on this particular list. And again, so the kind of data that I'm adding is kind of arbitrary. So I'll just pass it along as a void star. I can copy that pointer into some node object. So what I'll do here, I could also create a constructor for a node and a destructor for a node. But I'm just going to go ahead and make that node here. This is kind of an internal thing. I don't really want the user to have to worry about. So I'll just say, okay, struct. Let me just make a new one here. I'll say struct node star equals node is equal to, okay, well I guess this is going to be the new head. I'll call it the new head. Equals struct node star malloc size of struct node. All right, so hopefully that makes sense. I don't have a new in C. I have to always call malloc. And in this case, I want a single node object, so I need to know how many bytes that is. Actually, out of curiosity, let me print how many bytes that is. So I'll say size of struct node equals, let's see how big it is. Sometimes C will put a little bit of padding. So, I look at this and I think it's probably, there's 2 pointers here. I'm in a 64-bit machine. So that would be, they would each be 8 bytes. So I would think probably this is 16 bytes, but sometimes they pad it a little bit. But just out of curiosity, let's see. So if I were to say size of struct node. All right, let's just compile this and run this real quick, and then I'll finish add first. Unknown type linked list, use struct q. Oh, yeah, okay, yeah, I do this a lot. You always have to say struct linked list. Okay, there's a way to address that, but I'm not going to. You can use something called a type def. But, okay, anyway, so it doesn't like the I because this is actually a long, okay, whatever. But I'll run it anyway. Okay, so linked list. Okay, I was right, 16 bytes. So hopefully that makes sense. For a node, I've got 2 pointers, each is 8 bytes on my 64-bit machine. Okay, but that was an aside just to make sure you're following along with the mallocs and all that stuff. But let me finish this add first method here. So if you remember, and you might want to go review this, but when we add something to the beginning of a linked list, we first need to make sure that we remember what's currently at the beginning of the linked list, right? So let me actually first remember what the current head is. So that would be list head, right? And what I'm going to do is make, okay, so I've just made this new node. And I'm going to say, okay, the new head's next is whatever the current head is, right? And then finally, I can make the list head actually be the new head. Okay, it's very important to do these in that exact order. Otherwise, you end up making something that points to itself. This is something that I really nail home in my data structures classes. All right, but that should be good. And so now I can probably finish up the free method, because what the free method has to do is, okay, maybe I've called a bunch of these methods to add things to the linked list. What the free method should do is loop through starting at the head and delete everything that is there. So I could say, all right, let's make a, I'll call it node, so some cursor that walks through the linked list. So I'll say struct node. It starts off as the linked list head. The linked list could be empty, so it could be null from the get-go. But I'll just say while node is not null, then I still have stuff to clean up, right? So let me actually just quickly, before I delete this node, let me see where I might need to go next. So I'll say node next. Now I can free the node. And now I can set the node to be the next node. Okay, I've written a lot of code. Let me just make sure I compile it, and then I'll write a little more code to test it. Okay, good. No warnings or anything. We seem like we're in good shape. So let me just make one more method here, just to print stuff out. So I guess what I'll do is I'll make an example where everything in the linked list is like a string or something. So let me make a method called void linked list print, and I'll pass along the linked list. And so what this will do is it'll go along. I'll start off kind of like I did here. Oh, now I'm finished this, so I can say, step 1 was clean up nodes, and then step 2 was free the list. Okay, but anyway, I'm going to start off the same way down here with linked list print, and I will also have a while loop. I'll say while node is not equal to null. What I can do is print that node. So I guess I'll just print out, I'm assuming these are strings. So I'll print the string followed by a little arrow to show how this is linked list. So this is going to be node. So I guess I'll have to cast the void pointer of the data to a character array pointer. So this will be node data. Maybe, yeah, I don't know. When I'm done, maybe I want to print a new line. But yeah, okay, so in the loop to keep this moving, I'm going to say node equals node next. Okay, so let me, down in my main here, try to do some stuff where maybe I'll add a few things to the linked list. And of course, when I'm done, I need to make sure to remember to call this free method. Okay, so whenever I'm done, I'm going to say linked list free list. Okay, so let me add a few things to this. So I'll say linked list add first. Let's add Chris. Now let's add Celia. Now let's add Theo. And now let's add Layla. All right. And so what I'm going to do is say linked list print. And it should be Layla at the front, then Theo, then Celia, then Chris. So I'll say linked list print, and I'll pass along this list. Oops, I forgot. Okay, see, I'm so used to programming other object-oriented languages. Of course, all these methods are going to have a pointer to the struct as the first thing. I need to know what struct I'm doing this on. So I forgot that in all these here. All right. So let's get that all in there. And then I'm going to compile this and run it, and hopefully it'll print what I expect. Let's see. Linked list. Oh, it says null, null, no. Ah, so one thing I forgot to do in the add first, of course I have to copy the data. And the whole point of this is I want to encapsulate the data that I'm passing along. So when I make this new head, not only do I need to set, keep the structure of the linked list, but I should also set the data. I'll say new heads data is whatever data I'm passing along here. Okay, let's try this again. Beautiful. So we got Layla, Thea, Celia, Chris. And let me just check to make sure I'm not leaking in memory. So I'll run valgrind. And it says all heap blocks are freed. Now just to check if I were to forget to run this linked list free method, then I would get a memory leak. So now it says I've lost a bunch of stuff. All right. So the 8 bytes directly lost, that would be the pointer to the linked list here that's been dynamically allocated. And then indirectly lost the 64 bytes, that would be, so I have 4 nodes, each of them is 16 bytes, right? And so, okay, 16 times 4 is 64. So hopefully that makes sense. Do not forget to free your memory, okay? And with the linked list, when we free it, we have to loop through until we clean up all the nodes that we've dynamically allocated. But there you go. This is a linked list in C, and this will totally work. So I'm just going to have you do a quick little exercise with this, and then we'll move on and talk about file descriptors and actually where this sort of thing is relevant. Amazingly, there's some linked lists that are going to show up in networks right away when we try to use DNS.